Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. As I promised in the previous video, in this video we're going to cover prescriptive prediction. And that is essentially when we combine the predictive and prescriptive models based on the decision variables and the target. Basically, we make the target of predictive model the same things as the decision variables, and based on that we create a predictive model that instead of just predicting something, it tries to make a decision, right? So that becomes prescriptive prediction. So let's look at how that is going to be done. So in a predictive model, in this video we're going to talk about binary classification. In a binary classification, what we are doing, we basically try to find the patterns between the independent attributes and the dependent attributes. These being independent attributes and this being dependent attributes. We try to find those patterns, and based on those patterns, we run by the new data objects, or the data objects we are interested in calculating, knowing the class, the label. And we come to a probability value. We say, okay, the probability of 0 is 75%, for example, and probability of 1, 25%. And this is calculated based on the patterns we were able to find from the historical data, right? So a predictive model would be when we would say, okay, since I am only concerned with prediction, let me just predict whatever the probability of 0 is greater than probability of 1, therefore I decide to predict 0. Or if the other way around, probability of 1 is larger than probability of 0, then I would decide 1. So that's when what we matter for us is the most accurate prediction. So in this types of model, we would consider a model with higher accuracy a better one, right? But with prescription, what we want to do is to make a better decision, right? This better decision can be formulated in terms of profit, in terms of the least amount of damage to the environment. It could be any different ways we could formulate to sort of like evaluate a decision, right? And for example, here we want to evaluate a decision based on the cost of mistakes, right? So here, imagine that we've got the cost of mistakes for the mistake of false negative. So if we were to make a negative mistake, false negative mistake on this case, we would have to pay 5. Don't worry about the unit, just 5. And if we make the mistake of false positive, we would have to, sort of like it would cost us 1. And because now we have these probability values and we've got these cost of mistakes, we could try to minimize the cost of mistakes using these probability values. Basically, we would try to find the most, or we will try to find the least expected value of cost based on these probability values, right? So the expected value of false negative cost is going to be, the expected value of false negative cost is going to be 0.25 multiplied by 5, so 0.25 multiplied by 5, and the expected value of false positive is going to be 1 multiplied by 7.5, right? And then because there is the expected value of false negative is larger than the expected value of false positives based on these probability values, we err on the side of not trying to make false negative mistakes. So because we don't want to make false negative mistakes, there is more cost associated with it, and not only just from the perspective of the cost, but also probability that we have found. Then we will decide prescribed one, right? So here we didn't just try to come to the highest accuracy. We are here trying to come to the least cost of mistakes. So this is a decision. So pay attention here. Our target variable, what we were trying to predict, is the same as the decision variables. And when we sort of like put these together, make these two the same thing. Now we can be creative about how am I going to be evaluating my model. I mean, you could stay away from accuracy. You could say, okay, now I want to evaluate it based on the cost of mistakes, based on the profits. That is, if you can calculate or formulate those evaluation metrics. So, as a final thoughts before we get into an example and we see all of these in an example, basically when we have a prescriptive prediction, right? Prescriptive prediction models, we've got two stages. The first stage, it's pattern recognition. We find the patterns using the algorithms from the data. It gives us probability values, and then we've got risk analysis. Using those probability values and the cost from the environment, now we can do some sort of risk analysis that gives us the best evaluation function, which is the objective function. It could be cost, could be profit, so on and so forth. All right, so let's look at an example, right? So here's our historical data, right? So you can see here in this data, I've got these independent attributes and this dependent attribute, right? And I've got 3,000 of these customers' data, right? Based on now, I can have the opportunity to use an algorithm to try to find the patterns among the independent attributes and the dependent attributes. See if there are meaningful patterns that can help me predict if a customer is going to churn or not, right? So that's my historical data. But also I have the data of current customers. These are the customers that I don't know if they're going to churn or not. These are the customers I want to make decisions about. So see, these are my current customers. I do have all of the independent attributes that I can make a model. I mean, I would make a model using the historical data, but I also have the cost of false negative and false positives regarding each of these customers. This means if I were to make a false negative mistakes, how much would I how much consequences in terms of dollar amount it would have for me? And if I were to make a false positive mistake, how much consequences it would have for me in terms of dollar amount, right? So these are, values that have been calculated already. Normally calculating these requires a lot of digging, but just for the sake of practicing, let's say these are the values that we can work on. These are the actual consequences. And now we want to see how we would go about, if we have such data, how we would go about using a prescriptive prediction here, right? So let me open my R environment. Don't forget to set your working directory. I have already done that, and I'm going to go ahead and import my modules and packages. All right, so I go ahead and read my data. This is the historical data. My data is read, and I make sure that the R recognize the churn column as a factor or as a class, and then I also don't want to include the X. This X, because this is just a index, so I don't want to include that. So I get rid of that using this line of code, and then I use the R part, which is the decision tree algorithm. Let's just use decision tree to do my pattern recognition. I want to find those patterns, right? So I run this, and it gives me the summary of the model. And I can also evaluate very simply how well my model is doing. I can see that I've got this ROC, which tells me the model is getting something. I mean, it's way above the this center diagonal line, which is the random predictor. So it's actually finding some meaningful patterns in data. And I can also see the AUC is larger than 0.9. So I am finding some meaningful patterns, right? So now that I was able to do this, pay attention. This part is very summarized. Normally you would go about finding the best algorithm, tuning that algorithm. There are a lot that goes on here for you to be able to find the best possible prediction, best possible patterns. But I'm just, cutting through all of that because that's beside the point here. We've got the best patterns, somehow with one algorithm. So now that we've got that models that can actually use those patterns to give us the probability value or prediction. Now I read my current data, which are the data that have the independent attributes, but at the same time has false negative and false positive cost, right? So I go about predicting those, but this time I get a probability value, and I know the second row is the probability of churning, right? This is probability of 1, probability of churning. So I grab that from here. That's probability of churning, right? So that's probability of churning for all of the 100 customers in that current customers I want to make decisions about. So I calculated this decision of churn. If we decide to churn, how much cost I should be expecting, right? The amount of cost I would be expecting if I were to decide the decision of churn, say, okay, this is churn, could be, if I make that decision, it could be that it's going to be 1 minus churn probability multiplied by the false positive. Think about this one. And I calculate that, and I also calculate what's the cost if I were to decide not churn for each of these customers, right? So these are expected values, right? We've got the probability value. We don't know what's the future is going to be. We just have a probability value. And we find the expected cost of deciding churn and expected cost of deciding not churn, right? So now we can put these together, right? The expected cost for, let's go through from the beginning, right? So the expected cost of deciding churn for customer 1 is 64. The expected cost of deciding not churn is 2.8. So what should we do? We should go with the side that has least expected cost, right? That's very simple. So we do that for all of these. We actually can see most of the time the expected cost is very low for not churn decision. But for a few of them, for example, here, let's see if we can find anything here. For example, here, right? This would be the expected cost of deciding for deciding churn is less. So in this situation, we would decide churn, right? So we don't have to do this by eye. We can actually do this by a conditional operation here. You can sort of like do that for us. And then these are all decisions, and we can put all of our decisions and all of those costs and the probability values next to one another to sort of see what we are dealing with here. So for example, here we can see most of the time when we've got a true, the probability of churning is also high. But pay attention, it's not always 0.5. It's or 0.7. It depends on the situation of the customer, right? For example, here we've got 0.7, but it's still false. But we've got 0.6. This is true. This is because perhaps the cost of false positives for one of them were just way larger than this other customer. And so on and so forth. Here we managed to come to a decision, use a predictive model, and use risk analysis to come to a decision. And when we can do that, we call that a prescriptive prediction. All right, until the next video.